We're live. Hello, everybody. I am Verde Arbusto, and this is the Schumann Resonance Harmonics channel on YouTube and Facebook. Thank you for being here. I appreciate your support. Please remember to like, share, comment, and subscribe to this channel. Get updated on what I'm doing. And as I've been putting out more videos, I'm addressing what is recent and what is important. So, if you want to be updated on some space weather, but definitely all the Schumann resonance stuff, make sure you stay tuned here, please. And tell your friends. Send it to a random person on your contacts list, and let me know what they told you back. All right. So, this is kind of a multi-part. I'm doing a little bit of short videos. I've already I mentioned in another video about the CME. This one is going to be, I'm going to talk specifically about the recent CME, coronal mass ejection, that came off the sun. And so what you're seeing here in the background, this right here, is, okay, you look at this here, you look at this there, you see, oh, well, hey, that's obviously this is obviously that. Well, you got to match up the times, right? So first off, the time here is the middle of the day. So we're starting out their local time, 12 o'clock, okay? That's midday, 12, 1, 2, 3, 4, 5, 6, 7, 8. 8, 7. All right, so right there. So this is the hottest part of the day. This is the where the sun's overhead. And those of you who've been around for a while know that the diurnal variation means the difference between the daytime and the nighttime reading. So the daytime, as we know, the daytime is going to be stronger because it's a direct solar influence. What happens is the D layer tightens up. Okay, so we are getting solar influence, but you got to remember there's there's a waveguide cavity, and the waveguide is in between the ionosphere and the earth ground. So the waveguide, which is usually an insulated space, that's where the Schumann resonances occur. Most of the Schumann resonances occur because of lightning. The discharge from the ionosphere to the earth ground. The magnetosphere and the ionosphere help protect us from a lot of solar radiance that comes at us. So it comes from the sun, and then it kind of envelops around the earth. And it's pretty much through the lightning discharge that we get the majority of electromagnetics from the perspective of the amplitude and the quality. Okay. So what we're looking at, this right here, it says that's at the 25th, around 6. All right, so by 6 a.m., that had passed us. Okay, but we're in the middle of it. So at 6 a.m., right, it's gone. This is what's showing at 6 a.m. This is already gone. All right, so let me, I'm introducing this, that you got to look at the time component to this. And in case I haven't said this, this is on my website, and go over, check it out. I did the little graphic there and kind of did a screen capture so you could get a general idea of what that wave front looked like. And it was different from how they have it here. Is a little different than what they predicted a few days ago. All right, so ISWA, let's go over to ISWA. All right, so this is our chart in motion. You can see, I'm going to let it play a few times. So right there, as it hits right there, it's showing you, boom, the 25th. Boom. All right, so I'm just showing you that to give you an example. All right, so this is our Schumann resonance. So that big blast we got could have very well have been that right there. All right. 21, 2, 3, boom, right there. That's when it hits. So the 24th, it's like the first thing that we see is would be on the 24th, all right? So this is what we're seeing here. I'm pretty much certain that was this right here is what we got from that blast right here. All right, this would be my assessment and my guess. Okay, it's hard to line it up hour for hour, and you also have to remember again that this stuff compresses the atmosphere and the ionosphere, and as a result, the resonances do that. You know, when you compress it, they still do that. They shake. So this is the process. That's the end result of these kind of blasts here. Is that it compresses the Earth like a squeeze box, I think. And then oftentimes, when it comes back into shape, you'll get a low or you get a dip, which kind of happened there. You can see, you don't really see much there. It stays stable. The frequency kind of rises up. Okay, but that's stable. And so even though it didn't, well, it kind of does drop there. But this right there, I was mentioning this in the last video, after this kind of episode there, and releases, see, it kind of does drop, boop, boop, boop. It kind of drops down there, kind of returns back up. You know, it's not a conclusive thing, but you can see it does it drops a little bit, then it kind of goes back up there. All right, you can definitely see it's dropping there, and that stays kind of stable. But that was a big dip, and I'm gonna say it drops a little bit. It's hard to tell, not that much. It's not conclusive, but that's just generally the process, you know, that happens with the Schumann resonance. Well, it dropped. It did. It went to, and it kind of bottomed out. That's sort of what happened, right? That dip, but then it kind of returned up. But yeah, it bottomed out. Yeah, close enough, good enough. All right. All right. So you see that the range of that is this is the proton count. So when we're in here in the red, the yellow, you look at this red, yellow, greenish. You know, that's not that strong. That's in the lower kind of quarter of it, so it's not that strong of a signal. All right, you know, that's good, but it's a fairly dead-on hit. You know, we didn't take the blow of the strongest stuff on the fringes, but, you know, I would say that's probably why people are getting headaches or whatever if it's not your local environment. You know, so we get a spot-on hit like that, you may be feeling it. I don't know. All right. All right, so I showed the Schumann. All right, so this is, let's see what Kumyania says. And this is, the website is vlf.it, Kumyania Live. All right, so I've mentioned this before. What you're looking at here, this is the view meter, the decibel meter. And the colors are showing you where on the chart. Again, this is amplitude. The decibels are amplitude. All right, that's the intensity of the signal. So the color, you got to match up the color where here on this it is. You see these dark blues? It's here. This dark blue is black. Right, so this is black right there. All right, what I would call black. All right, that's just showing you a low spot of that as you go up into the blue, the navy, the blue, the cerulean, the yellow. You're getting pretty strong. You know, these are fairly strong signals, but this one here, see that red one? That one went over the top. It's not over the top. I was going to say went over the top, but no, it's just into the 50%. See where that mark is? That's 50% right there. All right, so when you start getting into a positive number, and these are negative. Once you start getting into a positive number from 0, and that's sort of what it's telling you, it's a strong signal that's up into, it starts going into the positive range. All right, so you see there's a little burst here up to 105. They capped this at 105, you know, and this is boop, boop, a red. The red, you got to remember the red, this is amplitude. All right, this right here is the seismic meter. So you got to match up these colors here, the seismic, with these, whatever the color happens to be. So you see you kind of get a sense of, once it's in the white, the yellow into the white, it's like that's a strong ass signal. All right. And this is the seismic meter. So that's picking up earth movement activity, okay, associated with, you see how the resonances are kind of picking up here. The horizontals are resonant. These are the resonances, okay. These are the Schumann resonances. That's 7.8, that's 14.1, that's 21.7, 27.1, and you're just barely skimming 33. You can't even really tell, and that's 45 up there roughly. Not quite 45, but that's 40 something. Yeah, 39. That's the next one up. 33, then 39. So you see the magnetic resonances are strong, but even here, see it's a little, this area here, this is, this is 2 in the morning here. You'd expect everything to be kind of sleepy there, but that's why in all these charts, you see the variation between the daytime and the nighttime. It's not something they're doing over there. It's not censorship, blah, blah, blah. All right, so this is a spike. And generally, these kind of spikes indicate, seismic activity, and there you go. Right? Spot on. Look at that. That's seismic. Yeah. All right, so this is your multi-strip. And this is an interesting, they're showing you the geophone trace. I'm going to have to find, I think that's a noise in the signal. I'm going to have to find out what these traces are. Okay, so this is the induction coil part of it. You see very strong magnetic signal. And I mentioned this before. You got to match up the color here, matches up with somewhere on the grid here. So these greens, this is the direction that magnetic wave is moving in. And that's what all these colors are. It's showing you the strength of that up to the vertical frequency. But what you got to look at is the color. Match the color up with the direction. Okay, so these blues, nice blue, you see that? That's that direction going south. And it's an interesting, if you look at it long enough, you start picking up some interesting patterns of movements, right? It's interesting, fun, trippy, multi-strip, they call that, But again, that's what you're matching up the directional. I'm calling that the directional. I'm not sure what the heck else that is. To somewhere on here, and you see these colors here that are interesting, like that, blues, you start, it's movement. Quality is magnetic flux. Flux means movement. So current is a direction, north to south, east to west, but that's what this is. It's a current. That's the Earth's magnetic grid. The Earth's power grid is current, and that's how it moves along in a line, but in a direction, based on the ley line system. But it conveys power and current within the Earth itself. Okay, that's the best way to put that. The Earth's telluric power grid keeps the power flowing in the Earth, and it's not a expression into the atmosphere as people believe it is. The Schumann resonances happen in a different chamber, in a different place than the Earth, as if it's coming from the Earth. The Schumann resonances are bouncing around in the atmosphere from the Earth ground to the ionosphere. And generally it's coming from the ionosphere first, but lightning has been known to go from the planet up into the sky. And as the magnetic grid is weakening and the poles are shifting and all of that, there has been more sighting of ground to sky discharge, lightning discharge. from the ground to the sky. And you see it a lot more recently than you have in the past. All right. Okay, so I moved that, so hopefully we can see this now. All right. Okay, so what does Etna say? All right. Actually, hold on. Okay, much better. All right, so this is the Etna Radio Observatory. And I got this from vlf.it, and there's all kinds of interesting stuff. So, in fact, this is on my website. The link to this is on my website. And you'll also find a number of other sensor sites, I think is the best way to put that. Comiania is one. Etna is another, and they have them all over Italy in various places. Okay, Etna. All right. So they give you a little picture of the induction coil. These are very interesting kind of articles from Ronaldo and the VLF crew over there. So these guys are giving the monitor of the Italian network. I have talked about these guys before, the CIEN, which is the Central Italy Electromagnetic Network. And around the countryside of Italy, they have a number of these monitoring stations that are monitoring VLF and LF, low frequency, as well as seismic meters. And they're also, in some cases, they're measuring more than that, like ground salinity and just a number of different things. Humidity in the environment. They measure a number of different factors, which they don't show here, all right, just for what it's worth. But also the magnetic component. All right, so that's what. Do I have it? All right, it's down here. So, all right. Boop, boop, boop. No, they don't. Actually, these guys don't have the magnetics, but they have the seismic activity, and this is what I had want to show you. All right. So this right here, again, we match up our colors. So we're looking, maybe you're like here, this color frame here. All right, so that's about 75, negative 75 decibels. All right, so that's what this is at here in this 3 hertz range. Look at how slow, or this would be, I guess, 4 to 5. I think that'd be the end of it is right there. So that's maybe 4 to 5 hertz. That's very, very, very low. And that's with the intensity, 3/4 of the intensity or I guess a quarter of the intensity that way. I'm not sure how to say that. But you see negative 75. It's coming up there, it's starting to get up there. This is the real-time lightning meter. And when I try to explain these, I know more, but I'm trying to put it so I can explain it to you in simple terms. This is the biggest problem I have, is not telling you. I'm fine with giving you any and all information. However, what can you hold on to in your head? How can I explain this? The words. Like, there's needed words to describe more words. That's why the pictures are here, so I can give you some, I couldn't do this without pictures to show you. And of course I wouldn't really know anything without pictures either, I guess. So this is the magnetic field. Here it is. And they're measuring it. They got, instead of the white, the other one had the white. This is the intensity of this, all right? It's not giving you the direction. Coming from, all right, so they're giving you a frequency here and an intensity here, all right? Now you look at this, it's only going up to, this is like 8, 9, or 10. 10. This is only going up to 10 hertz. All right, I want you to look at that. It's only going up to 10, but there's an intensity that happens here on the lower spectrum of the Schumann. Right here, stuff that happens here that you don't think about. But look at this, 4 hertz. What's happening? And I'm not saying this is it, but what's happening here at 4 hertz? I just showed you. Right, this seismic activity this is stuff in the low end, but it's just, you see, it's seismic. That's the earth moving. It doesn't get much more important than the Earth moving, right? I mean, that's what's causing the seismic activity, and it's releasing boop, energy that's coming out in the form of amplitude that's getting measured here on these charts somewhere. And the induction coil, remember, this is the magnetic portion of it, right? You're measuring the ELF and ULF. That's extremely low and ultra low frequency magnetic field. And this is for Etna. They have an active volcano there, right? So they're measuring low frequencies for Etna. All right, we're at 20 minutes. All right, we're doing okay with time, I guess. All right, so this is the from Discovery, volcanodiscovery.com. This is the recent earthquake map here. All right, so trying to get the picture over there. We go. All righty, look at that, fabulous. All right, so this is the earthquake map. You see a big one here in Fiji Islands 9 hours ago. This one here in China. These aren't too big, 5.4. But the fact they're reporting any at all in China is pretty amazing. Bunch. Look at all that. Oh, an hour and 13 minutes ago, 12 hours ago. Nice. All right. And if I'm not mistaken, there's a huge supervolcano somewhere between China and North Korea, I think. If I remember, it's over here. All right. Pakistan, these guys regularly get hit over here. Iraq, Turkey, Greece. All right. So we see Etna. They're giving you Etna. Look at that's where Etna is, right there. Okay. And you see Greece got hit. All right. So Etna is right here. That's not that far from Greece. All right. Etna's not going, but Greece is. All right. So when you see these low-level quakes, a lot of times in seismically active area, a lot of times it's magma that's moving around. All right. All right, Portugal has gotten hit. All right, so let's just scroll down here. Got some 3-4s, 3-4, 4-7. That's in North Pacific. All right. Here's one 5-2. This was that's the 26th. This is 6:28 GMT. All right, 5.6 near Kazakhstan. All right. These are all 2-2s, 3-8s. Ionia. They have a university there, and they did a great article on making a Schumann antenna. This one 4.8 in China. I should be scrolling slowly so you can see. All right, so this is just a volcano update here. Hopefully you can kind of read that. And then there was one. There it is. No, that's not it. 5.0, New Zealand. 5.2, New Zealand. All right, that's interesting. New Zealand's getting hit. Where is it? There was a big one, I think, 2 days ago. Wow, that's a lot. Oh, this is interesting. It says estimated combined seismic energy released 3.8 times 10 to the 14th joules, which is 107 gigawatt hours, equivalent to 92,004 tons of TNT, or 5.8 atomic bombs. Oh. Interesting. All right. This one here, well, that's interesting. 3.7 on the Richter. There's almost 400 reports that felt it. Okay. All right, so this is the, oh, there it is. That was it, the Fiji. Okay, no, I already gave that one. All right, okay. All right. There's a lot. That's a good number. All right, that's your earthquake update. Speaking of which, there's your Yellowstone earthquakes. Speaking of, updates. All right, so it's getting tons of them. Look at it. 1 point. They're all tiny. That's all magma. All these are magma. This is not so much tectonic, but it's magma that when magma moves underneath the surface and it knocks loose old old material that was there, you can feel it shaking. And so that's why they monitor the ground for shaking, because when an eruption is imminent, the ground will shake more. However, these guys keep kind of pushing the bar off, and you see more earthquakes, and they're just like, no, don't worry about it. That's kind of their attitude about it. They shut off the monitors, they shut off the meters, turn to crank everything up, and to the point that it's like, man, you guys are in active denial. There's not another way to put it. Okay, and so here's a really good, interesting look at where the seismos are, and you see there's a good deal of them, 26, 27, 28 maybe. All right, so Mary Greeley, if any of you follow Mary, she gives you the earthquake, the Yellowstone update with the earthquakes and all of that, and she follows it around the world. So I'm not going to step into her territory, but she'll give great Yellowstone updates. But one of the things she talks about is these that are marked in the red are earthquakes that the geologists are supposed to come back and look at and, evaluate and mark them. And a lot of times what she says is that they don't, and I can believe it. Ooh, look at that. What the heck happened there? Wow. That's like modern art. I don't know what kind of reading that is. I have no idea what that's about, but that looks pretty, pretty intense. All right, so you can see all the red. Like those are legitimate earthquakes that they're supposed to be picking up on. I guess there's not too much today. All right, and so this website here is geocenter.info. And they do some pretty interesting stuff there. I've seen stuff. And they have, like, here you have all kinds of interesting stuff, videos. So I'm not necessarily... they have good information, the science. Go there to check out the science. All right. All right, so I think that is the... I'm almost at 30 minutes. I think that's probably a good place to stop. I just wanted to kind of give the space weather update. I think there's more I probably could go into, but I think this covers all the basics. The KP. Let's see what the KP is doing. Okay. People look at the KP, and a lot of times I don't really know what it is that they're looking at, but you have to understand that the KP is an index. There's a bunch of magnetometers that are hooked up together into a network. And what they do is they take an average, I think. There's an equation and all of this, and there's math that's involved, but they take the average over all of them and give you the index. And so the KP index regularly changes. Only like every 15 minutes it can change. And so that's something to note as well, that the conditions are maybe red right now, but you come back in half an hour and it won't be showing you red. It'll be showing you a different signal. So, that's something to notice with that it's not a direct one-to-one measurement. The KP index, put it this way, the KP index is a measurement of the magnetic field, but it is not done by one single machine. It's done by a number of machines, which they aggregate information from. Okay, proton flux, a lot of stuff on here I don't even know. It's interesting and fun to read. There's the auroral forecast. That looks pretty strong. Yellow area, 50%. It's pretty strong. See how far down it's coming here? I'm thinking, you know, as these poles shift, we should be starting to see the northern lights here in the northeast, the U.S. I'm suspecting it. I'm suspecting before my life is over that I will probably see one aurora in the sky. I already see all kinds of neat things, rainbow clouds and all kinds of neat stuff. All right, so I'm not going to play the video. This is an old video, but any of you that have been around for a while, at least with me, you know that I support Suspicious Observer, SO, Suspicious Observer. He's got, you know, he may be a little bit arrogant, you know, and a bit of a pompous jerk in his comments or how he approaches people. I'll give him that. He's not exactly a people person, Dr. Ben. But I have a lot of respect for what he says, and the science is all good stuff, and he's saying things that no one else will say based on science that is not very popular, but it's, as time is going on, it is starting to prove more and more what he and the plasma cosmology view of the universe says. All right. So, all right. Oh, something I'm not sure if I mentioned this. All right. So this is Earth right here. You can tell what's what from the little graphics here. You know, you follow the orange colored circle, that's Mercury, the green one, that's Venus, this is Earth, and these square ones are the satellites. So the stereo A is this one here, stereo B, or I'm sorry, that's stereo B, that's stereo A. The SOIO, not sure what that is, that's that one there, and Osiris Rex, that's there. All right. Let's go back. All right. So I think that's about it for now. I'm at about the end of where I should be, and I think we'll call it a video. We'll call it a day. All right, so thank y'all for being here. I appreciate all the love and support, the comments. And you know, I'm here. I'm still doing this. I haven't left. I, you know, I've been going through some stuff. You know, my mom's birthday was, you know, a few days ago. She passed on a number of years ago. And you know, I can't help but feel alone. You know, my family's gone. Everyone was gone. So it can be tough to wake up in the morning. And I've said this before, without you guys giving me support, and you know, I do this for you. You know, I already know. I don't throw this out here like, oh, what do you think? I'm happy to know what you think. I want to know what you think. Okay, especially there's a few of you. There's about 24 of you that I want to know what you think, but not like because I'm not sure. You know, I mean, I'm pretty sure on I'm 100% sure on the Schumann. Well, mostly sure on the Schumann stuff, the space weather. But anyway, it's about, you know, like, you know, having a dialogue in this and discussion. And it's no fun kind of bringing this up all by myself without having anyone else there to give me feedback on it. You know, doing this by myself is no fun, right? I mean, it just isn't. So, I mean, I'm not doing this for myself. I'm doing it because I want to, you know, hear from you. Namaste.